Hello, welcome to the Machine Learning at Home. Today I will ask myself a question. Can we make a k-means clustering from the distance data? Well, I need to explain. So what is k-mean clustering? You can use it, for example, for the iris data. In that simple example, iris will make a classification and call the objects k-m from k-means, and we'll use the restricted iris data without variable number 5, which, as everybody knows, contains species information, which we don't need. We also need to provide number of centers equal to 3, for example, because there are 3 species. And for stability, it's good to provide number of starting points, and start equal, for example, to 5. Okay, and then classification will be ready. So within iris.km will be cluster object which contain numbers of clusters. We can compare these clusters with original species data using my package. So library Shipunov, and then we'll use function misclass, which will compare our classification iris.km cluster with original species data, which we omitted when we did a clusterization. Species. Okay, and we also need to provide option best equal to true. Otherwise results will not be very good. And you can see now the table of misclassification, which shows you, for example, that within versicolor 2 species were classified not properly. Within Setosa, because it's most distant species, all 50 specimens were classified in a proper way. Okay, but that everybody knows. Now I want to remind you my initial question. Can we do k-means from distances? So instead of raw data, we'll use distances. Let us make this simple experiment. Maybe distances will be better for this clusterization. So we simply will repeat this km, but instead of raw data, we'll use distance, which will calculate Euclidean distances between all points. And of course, we'll somehow rename this resulting object. Instead of km, use dm. So, okay, everything went well as usual, and we can repeat misclassification using now dm. Wow, you see, dm. So k-means clustering based on distance data is slightly better. For example, in versicolor species, 49 species were correctly classified here, whereas in a previous attempt, only 48 species were correctly classified. So as you see here, at least slight increasing of classification is visible quite well. So maybe if we calculate distance from the data first, it will be beneficial for us. It also beneficial for very interesting thing. While distance is a procedure which can use almost any characters. Of course, if you know how to make distance properly. For example, there's a govern distance, which is applicable to any kind of data, whereas k-means applicable only to numerical data, so you cannot use it for anything except numbers. What if our data contains numbers and also, for example, factors? How to make a k-means? Actually, there's no way, but with distances, you can do that. Let us make a simple experiment. First of all, we must create this factor data. For example, I will create factor iris dot pw uppercase from very simple procedure cut. Cut will split variable into several intervals. So which variable want to split? Well, we can split variable number 4, iris $sign petal width. It's variable number 4. This is YPV. And well, I need to split, for example, actually any number will work, 5 intervals. Okay, now iris pw is a data which we can use, like, for example, if we put a structure function we can see PW. What is it? It's factor, as you see, with 5 levels. So this is a data which is not numerical. And now if we apply typical k-means, it will not work very well. But we can use k-means from distances. And this is very interesting way. So for example, we can use Govor distance, which is embedded in Shapunov package. Govor distance. And use for Govor distance combination between original iris data. So we'll take iris data and remove now variable number 4 and number 5. 4, 5. Look how I made it, because it might be interesting. So I need variables from 4 to 5, and I put parentheses and minus. That will work. Without parentheses it will not work, please remember. And also I need to add here my new character with the function cbind. Cbind this iris data and new variable called iris pw. Okay, so I now can calculate distance of this interesting data, but I need also to make a clusterization, so k-means of all of that, and specify same options. Centers equal to 3, and also and start number of starting points equal to 5. Okay, and finally I need to name my new object. For example, it will be iris dot for example GDKM. Complicated, but represents what I actually will like to do. Govor distance with k-means. So, well, if parentheses are put correctly, things should work. Let us try it. Looks like it's working. And now we need to see how misclassification is stay for that particular classification. So GDKM also has a cluster. GDKM has a cluster, and we compare it with the species and use for best combination. It's very important. Wow! So you can see that misclassification error is now extremely low, lower even than for normal k-means classification, much lower, like 2 times lower. So as you see, this is a very perspective way. So instead of making k-means classification with raw data, you can use multiple different, hundreds of different distances, but Govor distance, for example, is good because it's applicable for many types of data. So now you understand that if you combine different statistical procedures, you can have sometimes at least a better result. By the way, many methods of machine learning based on combination, and this is one of example of combined methods. So this is it for today. Thank you very much.